So how does authentication work? In general, and then also specifically in React and Next.js applications. The core idea is always the same. We have our client, so our browser and the user visiting our page through that browser, and our server serving that page. The server also is connected to a database where, for example, all our registered users are stored. Now let's assume a user did already create an account, and now that same user visits our page and wants to log in. How does that work? Well, the user enters some data into a login form, like this form here, for example, in the login mode. So the user enters some data here and clicks log in. When that happens, we send a request with JavaScript to the server, a request which contains the user data, email and password, for example. Then on the server, we can validate that input. We can reach out to our database and see if we find an account for that email address, and if the entered password matches the password we find in the database. And then we send back a response which basically says, yes, your credentials were correct, you are authenticated, or which declines the authentication request. And then once we send back that yes or no response, though it's a bit more than that, as you will see in a second, but once we send back that response, the client can thereafter also reach protected routes and send requests to other endpoints on our server, to other URLs on our server that might require authentication. Like, for example, that profile page. We're only able to reach it once we are authenticated, and we also only can change the password if we are. So if that request is sent to some backend API, that the old password should be replaced with a new one, that kind of request should only be allowed and fulfilled if the user is authenticated. So that request which we send here needs some extra data attached to it, some extra data attached to the request, which in the end tells the backend that this user is authenticated. Because anyone could be sending requests to our API, and hence the request needs to carry some extra permission, which then should be verified on the server. And that permission part is important, because a simple yes or no sent back by the server to the client would not be enough, because we can, of course, always send a request to some API endpoint that requires authentication and say, hey, I'm authenticated. We can't just believe that as the author of the API. We need some proof that a user is authenticated. And therefore, authentication involves this exchange of credentials for permission, but the permission is more than just a yes or no. To be precise, we can't just save and use a simple yes, because a fake yes could be sent. We can't just tell a server that we are authenticated and then request protected data or perform protected operations. And therefore, instead, we need some proof which can't be faked. And for this, we got two main mechanisms. We got server-side sessions and authentication tokens. Now, these are two common approaches for solving this problem of unfakeable permissions. The concept of server-side sessions works such that we store some unique identifier on a server. So we generate some session ID, which is unique, and we store that on the server, for example, in a database, and we send that same identifier to the client that sent us the credentials. Then on the client, we can store that ID, that identifier, and then we can use that stored identifier to attach it to requests which we thereafter send to protected resources on the server. And then the server is always able to extract that identifier from the incoming requests, check if it stored that identifier in the database, and if it did, grant access, and if it does not, deny access. Now then only clients which have this identifier are able to send requests. Now you might say, okay, but can't this identifier be stolen? Well, whilst it's in transit, it shouldn't be stolen because we should be using SSL for encrypting the connection anyways. And when it is stored on the client side, it is stored in a cookie typically, and that cookie can be configured such that it's not accessible through JavaScript to prevent against cross-site scripting attacks, and that it is only readable from the server when it is attached to outgoing requests. And even if it would be accessible through JavaScript, you should be protecting against cross-site scripting attacks anyways. And if you can rule out cross-site scripting attacks, your authentication permission stored in some client-side storage is pretty secure because only you, the owner of this computer and the user of this browser, are able to view it. So you could only hack yourself. And some random dude wouldn't be able to just send a fake request to the server because whilst you could come up with a random identifier, the server would not know that identifier. So that's the concept of server-side sessions. The other concept is about authentication tokens. It's not that far off. The idea here is that the server does not store any identifiers. Instead, the server creates and signs tokens, which in the end are just random strings, you could say. Random strings which can be unpacked to data packages. So we take various pieces of data and sign them together, more on that in a second, and then such a token is sent back to the client. The client can then save that token and again attach it to outgoing requests to tell the server that access should be granted. Now, even though the server does not store that token in a database or anywhere else, the server knows how it signed that token. And I'll come back to that in a second. So the server will be able to verify if a token was created by it or not. And therefore, again, if I just come up with some random token string and I send this to a server to get access to some protected resource, access would be denied because the server would not be able to verify my random string, because it wouldn't be a validly signed token generated by that server. Now, these are the two approaches we have. Now, when we build a single page application, which we in the end still kind of do with NextJS, then we typically work with tokens instead of sessions. And there are reasons for that. For one, pages are served directly and populated with logic without necessarily hitting the server. Of course, when working with Next.js, you can build pages which use get server-side props, and therefore there will be a request handled by the server every time that page is being served. But you will also have many pages which are pre-generated, and once the user is on your website, many pages won't be fetched from the backend at all, but instead will be loaded and generated dynamically with front-end JavaScript. Because you still have a single-page application, at least for many pages that make up your website, after you initially loaded your first page. Then still, JavaScript takes over, React takes over, and handles your website. So that's important. You don't send a request for every page you visit, because you're not using get server-side props on every page. So the server doesn't see every request which you send. And therefore you load pages without the server being able to directly find out if you are authenticated or not. In addition, backend APIs which we use for single-page applications are typically stateless. They don't care about the individual connected clients. They don't keep track of all the connected clients. Instead, the idea is that that API can work pretty much on its own. And it just is able to hand out permissions to clients who authenticated so that they can then later request access to protected resources. The API itself does not store any extra information about any connected clients. And since this is how we build single-page applications, the server is not involved in every request and every action that's happening on our page, because we handle that with front-end JavaScript and we have that stateless API connected to the SPA. And because of all of that, we could say that we have kind of a detached front-end and back-end combination. They do talk to each other sometimes, but not for every action that's going on the page. And because that's the case, servers don't save information about authenticated clients, and instead clients should get that standalone permission which allows them to prove that they are authenticated. And that's why we use these tokens. And here specifically, we use a concept called JSON Web Tokens. That is simply the most common form of authentication token, and it simply describes the way the token is generated, though we don't need to care about that too much because we'll use a third-party library for generating and signing that token anyways. So as it seems, these JSON Web Tokens are important, and therefore we should take a closer look at them. We should understand how exactly JSON Web Tokens work. And in the end, a JSON Web Token is generated with three main building blocks. We got some issuer data, some data which is automatically added into a token by the server when that token is generated. That's some metadata which we typically don't set up ourselves as a developer, but which is pre-configured by the third-party packages we use for generating tokens. We can then still also add custom data to our token, for example, some information about the user. And then, very important, we also set up a secret key. We set up that key on the server. The client never gets to see that key, and that's important because if you have that key, you can create valid tokens which are accepted by the server. Hence, only the server knows that key. Then we generate a token with some third-party package by combining all these pieces together, by creating a random string that incorporates all that data and is signed by that key, and that is that JSON Web Token, a long string. The important thing here is that signing does not mean encryption. The JSON Web Token is not encrypted. You can unpack it and read the data inside of it without knowing that key. That key only proves that a given server created that token. But you can read the content of the token without knowing that key. The key, of course, will not be included in the token though, so you can't read that key, even if you unpack the token. Now, it's that token which then is stored by the client, so by the browser, and which then is attached to requests to protected resources on the server, so to protected API routes. For example, if we want to change our password, we don't just send the old and the new password, but we also include that token in the outgoing request. And that token then is validated by the server, which basically checks, okay, if I would use my signing key, which only I know, would I be able to generate this token? And if the answer is yes, the server knows that it's valid. If the answer is no, it's invalid and access is denied. So that's why we can't just generate a token without knowing the key. We can generate a token, but it would be an invalid one. And that's why this is a secure mechanism. Okay, that was a lot of talking about all of that, but that's the important theory, the foundation we need for then actually diving into authentication and implementing authentication. The great news is that we don't need to build all these things from scratch, but that instead for the token creation and validation and so on, we can rely on secure third-party packages.